Good morning. I'm here with Trevor Lang from HMS in the United States. Hello. Good morning, Trevor.
Good morning.
So can you explain a little bit to us about the demo that we are seeing here?
Sure. So this demo is a simulated machine that's controlled by a Rockwell Safety PLC. And on that Safety PLC, it's controlling a small motor through a motion controller, and it's got some safety built into it, some safety I/O. And in some cases, when the safety I/O needs to be remotely located from the machine controller, or maybe the safety I/O is mobile or moving, then we can use wireless technology. In this case, we're using 5G technology to connect the safety I/O up to a 5G base station, and then the controller is connected directly to that base station to be able to get the safety data to and from that I/O. And so we're just using this as a proof of concept to show how we can use CIP Safety over a 5G connection to control a machine that requires safety.
Okay, sounds really exciting. I know many people have not heard about safety before. Can you explain a little bit why we need this?
So safe operations of a machine basically are to help prevent personnel damage, equipment damage, and environmental damage. And so any kind of machine controls that could pose damage to any of those things needs to be mitigated. So there's I/O systems like safety curtains, safety switches for doors, light curtains that detect people in place, or laser scanners that detect people in zones, and all that could be used to put a machine into a safe mode to prevent damage and injury.
Okay, sounds really important.
Yes.
So the different parts we have in the demo here, can you explain about what they are doing?
So we have a motor that might be typically found in moving equipment, say conveyors, or even AGV devices, automated guided vehicle devices that move around a facility, perhaps picking up and dropping off goods at different manufacturing sites. We have safety I/O, which could be as hardwired things like safety switches. It could be laser scanners scanning an area for personnel or other obstructions, and then we also have a network, an Ethernet network controlling all that. But when that Ethernet network is inconvenient because of hardwired restrictions of hardwiring, then we use the 5G connection to establish a wireless connection to any component in the system that needs it.
Okay. I can see you have a couple of emergency buttons there.
Yep.
But there's also a red thing a little bit further down. I wonder what that is.
Oh, this part right here?
No, I'm thinking about the one with the metal bits sticking out.
Oh, this. Okay, so this is a machine key, basically. So in order for the machine to operate, this key has to be in place. And so to be able to remove this key, you have to put it into a safe operating mode. And then once you put it in safe operating mode, then you can remove the key to stop the machine from operating. And when it's ready to operate, then you can plug in the key, put it back into operational mode, and then proceed.
Okay, excellent. So I understand the concept you explained about safety, but why would we want it on a wireless connection?
When hardwired connections are either impractical or impossible. So having a wireless connection could solve a lot of issues where you can't get the safety data conveniently to the controller that needs to know about the safe conditions.
Okay, very good. Now I don't know if I'm out of question. Can you? We have this funny thing that looks like a lamp holder.
Yeah.
What is it actually?
So it is a 5G radio with built-in antenna structure. This is designed to mount either on a flat surface, say on the top of a cabinet, but it's also got this convenient mounting where you can put it on a pole with a bracket, and so you can put it in an area where it gets good reception and good signal. But the design is actually a unique design for that HMS has come up with, so that you can have a radio and antenna structure all in one device that can be conveniently mounted on the surface of a machine.
Okay, sounds good. Thanks a lot.
You're welcome.
Very, very good explanations. Thank you.